Good morning, class. Today we're going to be learning how to solve a different type of tree diagram. So if you're looking at this question here, we're going to start, and this is related to our own robotics team. Actually, the names on this list are from our first robotics team, so you might recognize some of the names here. The Panther Technics have a big competition coming up. At the game table, only 2 members can work together on a mission. If there are 8 total members on the team, how many combinations of partners can be made? Use the space below to draw a tree diagram and make an organized list of all combinations. Team members are Patrick, Evan, Tommy, Joshua, Chris, TJ, Bryce, and Demi. Now, as we're looking at this, we're going to go back through and use the cube strategy. So we want to circle all of the important math information. So I'm looking at there are 8 total members. Only 2 team members can work together. And then here is the list of the 8 members. I now want to underline the question, which is kind of more of a command too, because how many combinations of partners can be made is part of the question, but also it does tell us to use the space below to draw a tree diagram and make an organized list of all combinations. So we do need to identify that. The next thing is boxing our math action words. So one of the words that we always look for when identifying if it's time to do an organized list or a tree diagram is combinations. So that is what I would box. Now, none of the information in this story is really worthy of eliminating. Yes, we don't necessarily need to know that they have a big competition coming up, but that leads us to understanding what is happening in the story. It's more of a setting. It's not misleading. The only information we want to eliminate is information that would mislead us, like math information that is not necessary to solve the problem. So this is a little different than the previous tree diagrams because if we look here, we're allowed to have 2 members at the team or at the table. However, if I have Patrick and Evan working together at the table, that's the same as having Evan and Patrick working at the table. So unlike the ones where we're trying to find a combination lock or different clothing that they're going to wear, this one, we're kind of eliminating options every time we use one. So it's important that we start at the beginning, and we're going to start with Patrick. So I'm just going to use P for Patrick because this is going to get a little bit crowded. And if I choose Patrick as my first person at the table, then I have all of these options left for my second person. So that's 1, 2, 3, 4, 5, 6, 7. So I'm going to draw 1, 2, 3, 4, 5, 6, 7. And that would be Evan, Tommy, Josh, Chris, TJ, Bryce, and Demi. Now, here's the thing though. Every single one of these combinations includes Patrick. So there is no other combination that I need to make with Patrick being involved. Because if I start here with Evan, and I go to make a branch and I put Patrick's name here, well, Evan and Patrick is the same as Patrick and Evan. So I don't need to include Patrick anymore. In fact, I've already included him in every combination possible with him. So now I've eliminated him. That means that when I go to find out how many options are left for Evan, my number is going down a little bit. Now I have 1, 2, 3, 4, 5, 6 people. Because here, Evan is already working with Patrick. So now I'm going to do 6. And that leaves Tommy, Joshua, Chris, TJ, Bryce, and Demi. Once I've done that, I can now cross off Evan's name and move on to the next person, Tommy. And that leaves 1, 2, 3, 4, 5 for Tommy. Tommy can be with Josh yet, Chris, TJ, Bryce, and Demi. Because remember, again, Tommy's with Evan here, and Tommy's with Patrick here. So this is all that is left. So then I'm going to cross off Tommy's name, and then I can move on to the next person, Joshua. And that leaves 1, 2, 3, 4 for Joshua. Chris, TJ, Bryce, and Demi. I can cross off Joshua's name and move on to Chris. Chris has now 3 people. And you notice that it's going down every time I cross off one of those names. And then TJ is left with 2. And then Bryce is left with 1. So I can cross off both of them because Demi is included here, 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 and here. So there's no other combination left for Demi. Again, when I'm making my organized list, I'm just going to be going down here, starting with PE, then moving down. PT, PJ, PC, PTJ, PB, and PD. And then I'll move on to the next group. Now, once you get through all of these, it's going to be important to count up the total number. And if you count, you can double check by looking at, if I start counting here and I start here, here I have 7 possible combinations, then 6, then 5, then 4, then 3, then 2, and then 1. So I can count each of these over here and I will get 28, but then I can also count these individual pods and add them together. 7 plus 6 plus 5 plus 4 plus 3 plus 2 and plus 1, and I should also get 28. Now we can't multiply the variables in this case like we can in the other types of tree diagrams because we don't have 2 distinct or 3 distinct variables. We don't have 3 columns with different options in each column. So because this is, we're pulling from the same information, we're pulling from the names of the members on the team, and it's the same, and we can't duplicate, it looks a little different, and we can't just multiply variables. So then I'm going to go and write my answer statement. The Panther Technics can send a total of 28 combinations of 2 team members to the table. Good luck with the next problem.